Hello classmates, let's learn this lesson, Low Frequency Electronic Circuits Chapter 5, Negative Feedback in Amplifier. So, how do you tell if it's positive or negative? First, we have to decide, is there feedback in the circuit? Just to see if it has a feedback loop or a feedback component. Just if the output is from the whole circuit. A component is connected to the input, so what we call this circuit is circuit with a feedback. This element is called a feedback element. For example, let's look at the circle like this. Its output is 4 volts. Capacitance is short-circuited and AC condition. So this RF is component. I came out with a darker dot icon. RF, this element, is connected to both input and input. So RF is a feedback element. It has a feedback. Then look again. First, we find the output valve. Find the input side again. The input end is actually the base of this tube, and the emitter of this tube, because this is our tube base. And the voltage difference of the emitter is used as the input signal to control the collector current of the tube, so both the output connected. Output valve, it has 2 ports, one is D and one is valve, also connected to the input. That's the resistor Re. So this resistor Re is also a feedback signal. Previously, we learned to call emitter following resistance. Now, from another perspective, it is also a feedback element. This is Re as a feedback element that uses what you just learned. What kind of feedback is this? Do I extract a voltage or current signal? Extract is a current signal. This component does not extract the entire volt, so it's an electric current. Is this head in series or in parallel? It's in series. This is a current series. After a while, we'll have an example to practice. So how do you tell it's a voltage feedback or current feedback? The student on that topic just now feels a little confused at a glance. Teacher, you said that R1 is a current feedback. I'm a little confused. How to determine if it is current or voltage feedback? There are 2 main ways we can do this. The first method is what we call definition in our book. By definition, this method is the best, most direct and clear. But it can also tell 80% of the questions. The remaining 20% is not good enough. I can add this short circuit later. First, let's look at the definition. So on your left, you can see this feedback network extracts the entire output voltage signal. This is a voltage feedback. Output is voltage feedback. So what about the right image? I didn't pick up the whole voltage signal. Instead, the current on the load is extracted. Current on basic amplifier load. So the right one is current feedback. There's a way to define it. You can see it at a glance. Definition method preferred. The input end of the feedback network is usually in parallel with the basic amplifier. The output voltage on the load is extracted, what we call voltage feedback. Otherwise, it's all current feedback. So short circuit method. If this input side is AC loaded, AC short circuit at 2 output ports, I don't get feedback. So this must be a voltage feedback. For example, I'm short on both ends of the load. I can't get any voltage signal from these 2 ports. Short enough. No voltage signal is mentioned. So this is 1. It can also be determined by definition that this is a voltage feedback. So look at this, and I will output 2 RL, 2 poles, short-circuited. If the load becomes a traverse, I can still extract the current from loud. So it doesn't disappear as a feedback signal. So this is a current feedback. This is a short-circuit method, AC short-circuit output load. If the feedback signal disappears, so this is voltage feedback, otherwise it's an electrical feedback. This is the definition. This is short circuit. So take an example to practice. Let's look at the topic. The RF is the feedback element. Is it a voltage feedback output or current feedback? Definition method. Definition means if this RF extracts the voltage value of the entire output signal, that's voltage feedback. It is true that I extracted entire output signal voltage value. The output is a voltage feedback. Of course, I can also use short circuit method. Short circuit, of course. Capacitor short circuit when output in AC. Load grounding. Is VCC grounded, DC voltage source grounded? Then, if the output voltage signal, when AC short circuit occurs, nothing can be picked up because this is grounded directly. This is a demonstration that the feedback signal disappeared. It's just a voltage feedback. Both methods can be used. This is easier. We may be a little familiar with practice. Keep looking down. On the input side, how do we judge it? It's a side-by-side feedback or concatenate feedback, preferred or defined, of course. For example, the left side is in series, on the right is a parallel feedback. Then, this input and feedback on the input side in the form of the current overlay. It's easier to see that this is a form of current overlay. Look at the two ports I entered. The two ports of my feedback network do coincide, right? Look at the two ports of this feedback. This is a port, this is the second port, and the two input ports. This is a port, this is the second port, coincident. So this must be an overlay of currents. This is parallel feedback, otherwise, the voltage overlay is a series feedback. This is the definition. If it is a short circuit method, so if I short circuit this input signal AC, short circuit the input signal to AC, then the input source is a current source. It's a parallel connection of a current source and a resistance, or a voltage source in series with a resistance. So I shorten this whole input signal together. Now that I put this in, think of it as a voltage source in series with a resistance. Setting this voltage source to 0 is not the case. It's the value of 0 for the entire input signal. So that's where my arrow is pointing. When short together with the position below, this is called the input source AC short circuit for this signal. So this side assumes we take it. The input signal is considered to be a telephone with a current source and a resistor in parallel. AC short circuit seems clearer. This is the point where my mouse is located. Shorten with this point below, that is AC short circuit. If the input signal is AC short circuited, my feedback disappeared. So it's a parallel feedback. Otherwise, it is a concatenation method. Look at the right image. Right, if I hold the mouse at this point, if shorter than the point below, so do I feed back to the network? The two ports are also short together, so the ports of the two feedback are short together. It doesn't provide any feedback, right? Then its positive feedback disappears. That's what the short circuit method tells us. This is a parallel feedback, so the left side is the concatenated feedback. You mean I shortened it together, short this signal source together on the left. These two ports are also connected to the basic amplifier, also acting as a feedback. So the left side must be in series and the right side in parallel. Let's look at this example. Practicing judging inputs inside. Is parallel feedback or serial feedback? Input side, the input signal, is connected to the reverse input of. The signal it feeds back is actually. It is a current overlay with the input signal, overlay of currents. So the overlap of parallel currents, overlay as a current, so it's a parallel feedback. Some classmates said I didn't see it clearly defined or judged. You can use the AC short circuit I just said. This grounding the whole source. Grounded words, feedback signal directly to the ground has no feedback effect. Then the feedback disappears. AC short circuit feedback disappears. So it's a parallel feedback. Right, it's just a parallel feedback. So this side-by-side feedback is actually the input current. Make an overlay with feedback current. As net input current, make an overlay inside the amplifier. This parallel feedback. Let's take a look at R2. This R2 is connected to the output port. Connect to this reverse input port of the basic amplifier. So R2 is a feedback element. So this R2 is on the input side. Is it a parallel or a series connection? By definition, it provides a voltage signal and this initial voltage comparison for this input signal, acting on basic amplifier. So it's a voltage. It's a voltage comparison. It's a series feedback. But some classmates said, I still use the definition, but it looks unclear. Then use AC short circuit method. So this source is directly grounded. Discover this voltage after grounding. I will also work on the basic amplifier. So the feedback doesn't disappear. This can also be defined as a short circuit. Comparison of voltage signals, it is a series feedback. This is a definition method and a short circuit method to determine whether the input side is in parallel or in series. So more complex, like this. Differential amplifier circuits also have multi-stage cascades. How to tell if it's this input side? Serial or parallel feedback, basically it can be defined or short-circuited. So there are some handy. There are a few tips you can write down. For example, in general, this multi-stage amplifier, when this cascade multi-stage amplification occurs, then if the component's feedback signal of the feedback is then connected to first stage amplifier, when the signal input port is connected to the base, so this must be parallel feedback. For example, I have such a feedback element. It's the partial output signal, voltage equivalent to a total output is volt. Then I didn't extract the entire volt. Instead, it extracts volt related. For example, extract its current. Then anyway, it's the extracted output signal act on the base of the first amplifier by feedback signal. First amplifier base is rarely connected to the input signal, so definitely it's a side-by-side feedback. If you don't get here, or the other feedback is in series, for instance, look at this RF if it's attached to RE1. Don't look at it. It's a series feedback. This is a little trick. Everyone should write it down. A little special for differential amplifier circuits, or it's not special, just now I said it should be feedback element connected to the first stage amplifier. When the base is connected to the signal input signal, it must be in parallel or in series. Then, if you look at this RF element, it's the one connected to the output signal, or this part of circuit and the input port. The other base of the differential amplifier, it is not connected to the base of this transistor connected to the signal. So, in this case, it's in series. So there's only this RF on the right. It picks up the feedback signal from the output signal, connected via RF to end of this differential amplifier connected to the input signal at the base of that transistor. So this is a parallel feedback. Remember it with this little trick. Basically judge whether it is parallel or in series. Should be less difficult slowly. Okay, this is the end of this class. Thank you.